When we sketch logarithmic functions, we're going to be looking for 3 specific points as well as an asymptote. Starting with the points, it's going to be most helpful if we can figure out x values that will result in an argument that matches the base, because when the argument and the base are the same, this will evaluate to 1. It would also be helpful to find a value for x that allows the argument to equal 1, because then this evaluates to 0. The third most convenient would be if the argument is the reciprocal of the base 1 over a, because then this will evaluate to a -1. So when I look at the argument in problem number 4, I'm first going to pick out those x values. So I want x plus 5 to be equal to the base. My base here is 2. So that means x has to be equal to -3. I also want x plus 5, the argument, to be equal to 1. So that means x has to equal -4. The last place, I want x plus 5 to be equal to 1/2, 1 over the base. And that means x has to equal -4.5. I'm going to plot these 4 x values into my xy table. When I plug in -3, I get log base 2 of -3 plus 5, which is 2, which simplifies down to 1. If I plug in -4, my argument becomes 1. And if I plug in -4.5, my argument becomes a positive 1/2, which evaluates to -1. These give me convenient logarithms to evaluate and nice y coordinates to graph. -3, 1 is my first point. -4, 0 is my second point. And -4.5, -1 is my third point. Before I connect these, I'm going to look for my asymptote. Now, your asymptote in a logarithmic function is always going to be vertical. The easiest way to find it is by looking for the domain restriction. This argument, x plus 5, has to be greater than 0, which means x has to be greater than -5. Putting my asymptote then at -5 to show this domain restriction, and now connecting the sketch of my graph, making sure not to cross that asymptote. I'm going to walk through the same process in the second one, number 5, keeping in mind now that I'm changing my values. My base is no longer 2, my base is going to be 3, and also knowing that I'm going to have a different asymptote. So starting with the points that I want to use, I would like this argument x minus 1 to be equal to the base, so I'm going to pick an x value of 4. I would like the argument x minus 1 to be equal to 1, so that means my x value is going to be 2. Lastly, I would like x minus 1 to be equal to 1/3, so my x value is going to be 1 1/3, or 4/3 if you want to leave it as an improper fraction. Making my xy table here, plugging in 4, I get negative log base 3 of 3. So log base 3 of 3 is going to be 1. Multiplying that by the negative on the outside, I get a y value of -1. Plugging in 2, I get negative log base 3 of 1, which is going to equal 0. 0 times -1. And then lastly, 4/3, or 1 1/3, I get negative log base 3 of 1/3, which is going to end up being a positive 1. Log base 3 of 1/3 is -1, times that negative on the outside gives me positive 1. Plotting these points for -1, 2, 0, 4/3, 1 is going to be about here. My asymptote again is going to be vertical. Taking a look at my argument, x minus 1 has to be greater than 0, so that means x has to be greater than 1. So my asymptote is going to be at x equals 1. if you compare these two graphs, they definitely look a little bit different. The second one is actually a decay scenario, and it's caused by that negative on the outside, which is a vertical reflection. So it's flipped it upside down vertically.